Hello, this is Mr. Stansbury. I'm going to take you through the notes on one variable equations. Okay. At the end of this, you should be able to say, I can create an equation in one variable from a real world context, and also I can solve an equation in one variable. Okay, so first off, kind of a quick reminder, expression does not have an equal sign, an equation does have an equal sign. So if they're saying expression, like 6x plus 2, that's an expression. An equation is 6x plus 2 equals 18 or something like that. Okay, so that's the difference between expression and equation. So really, to figure this out, I really think our best bet is to take a look at an example here. All right, example: the Longaberger Basket Building in Newark, Ohio, which is a real thing, it's an actual building, needs to encircle the building with anti-ant fence. We can't have ants in the picnic basket, of course. They had to install 636 feet of fence. The length of the building is 66 feet more than its width. Draw a picture of the perimeter of the fence with expressions for the length and width using only one variable. So basically, first thing is, let's just draw ourselves a picture of the fence that's going to go around the picnic basket. So imagine the picnic basket building in there. It's like helicopter view. We're looking straight down on top of it. Okay. So we can say that this is, say, the length, and this is the width. But now it says, I'll write an expression for the length and width using only one variable. Okay. So now the key for this here is the length is 66 feet more than its width. Okay, so the length is 66 more feet than the width. So really we could say, oh, hey, we know that the length is 66 feet more than, so add 66 feet to the width, right? So wherever we see an L, we can actually put in W plus 66. So that's kind of our big key there. So we'll take L out, and we are going to replace it with W plus 66. Okay, so, and of course this over here is also going to be W, and this is also going to be W plus 66. So this is an expression for the length and width only using one variable, which in this case is W. Okay, so now that we have that, write an equation that would represent the relationship between the perimeter of the building and the total fencing installed. So we know the perimeter here is going to be W plus 66. So we got this one, and then we got plus another W, and plus another W plus 66. And then the nice part about this is it actually tells us that the perimeter, if they had to install 636 feet of fence, that has to be our perimeter. So this is going to be 636. Okay, so then now we just start simplifying. So 636, let's see, equals, we have 1, 2, 3, 4 W's. And then we have 66 and 66, which is what, 132. So that's a 4 there. So this would be a nice little equation that would represent the relationship between the perimeter of the building and the total fencing installed. Okay. And then we're going to go over here to C. But before we take a look at part C, let's take a quick little comedy break. All right.
Whenever there's a best of 7 series, because then I get to hear my favorite sports reporter question. Would you consider this a must-win game? You know, they always feel like they have to say yes. Yeah, we want to win it. It's very important, you know. Got our uniforms on anyway, might as well try. But it's not always the right answer, man. It's a math question. I wish I would answer that question honestly. It's a best of 7. You're down 1 game to nothing. Would you consider this a must-win game? No. No, we can lose tonight. We can lose tomorrow night, too. We don't want to, but that wasn't your question. You asked if it was a must-win game, and if you'd ever taken a rudimentary math class, You'd already know the magic number's 3. When you're down 3, then you must win them or you're out.
All right. Okay, back to this. C, using your equation from B, find the width of the building. So 636 equals 4W plus 132. So we're going to solve this thing for W. So we want to get W all by itself. So we're going to get rid of the 132. Opposite of adding 132 is subtracting 132. Right? Let's see. What's that give us? 504 equals 4W. Let's see. That's this 4W here. So this is 4W. Really probably didn't need to put that one on there. Yeah, because we're just subtracting 132 from both sides. All right, and then our last step is to divide both sides by 4. Okay, so we take 504, divide that by 4, and we get 126. So the width has to be 126 feet. Okay? Okay. And then the last one says find the length of the building. Okay, so we know that originally this was our length, but we turned the length into width plus 66, right? So to find the length is going to equal W plus 66. We just found out that our length is 126. So now we can figure out what the length is as well. 6 plus 6 is 12. Carry the 1, 6, 7, 8, 9. 192 feet. So that means the dimensions of this fence here are going to end up being, what do we got? We got this is 126, and then these here are 192 feet. Okay? Okay, that's all we have for notes for the one variable equations. If you have any questions about this or anything else, please feel free to ask. Thanks.